I'm going to do a talk on troubleshooting tools. Basically, these tools I use to debug systems. So yell.
Is it possible to talk out a bit?
Yeah, sorry. Do shout if there's any questions as well. What I'll do is go through the presentation and then at the end do a quick demo, which is basically how I solved a problem for Ian a few weeks ago, which conveniently enough was about a week before I had to do the talk. I've got to turn the mouse on, don't I? Come on. Whee! Right. So, basically everyone can troubleshoot. There's obviously, as you get more experienced at it, you can do more investigation, find out more problems that are going wrong, or even fix them. But I always think you basically need a bit of knowledge, a bit of experience, and some luck to fix things. So hopefully I'll help you to troubleshoot in the future. Click. First thing normally do if you've got a problem is write all the details down. So you've got the error messages, and the last thing that you want to hear is someone saying, I tried this and it came with an error, but I don't know what it was because I didn't write the error message down, because generally that's going to give an indication of what's gone wrong. The other reason you want the error message is because you're going to shove it into Google, and most of the time someone's going to have hit the problem before, and it can give you some indications to what to look at. I'll go into some other bits shortly. Right. So what you need to do is keep track basically of what you did to cause the problem, particularly if it's reproducible. If it's something that happens every now and again, it's quite difficult to. It can be quite difficult to determine what the problem is. Sometimes it might be happens every now and again, but it seems to be when the box is busy or something like that, and that can help. So the more information you can collect, the more useful it is. So as mentioned earlier, you've got to keep track of the error messages, that they're always essential, and also anything that's changed. So if you've done an upgrade on the box, for example, or whether it's a new program you're installing, so it's never worked in the past. If it's something that has changed, if it's something that used to work and now no longer works, and obviously something's changed to cause that to break, however it's a new program or a new installation, then that's not the case. So the web, obviously Google's the first place to look, and also the website for the program itself. Often there'll be later versions, so you can have a look at changelog files, news files that will say, oh, we've fixed some problems in these areas. There's also often forums or mailing lists that will have people also who are available to help as well. And there's also the bug systems that you can track things. So there's three common ones. There's Debian, there's Ubuntu, and there's Fedora bug system. And so if it's a problem that's on a particular distribution, then often you'll find more information there. So for example, there's one about Firefox and page sizes, which is because of something that Debian's done. You probably won't find information about it on Fedora or in Firefox because it's not their issue. It's a Debian issue, so you'll probably find it on Debian and possibly Ubuntu. When we get around to trying to debug the application itself, so I always go and check the man pages for verbose options or debug options to give you more information of what it's doing, what it's trying to do. So they're normally either a -v or a -d flag option. Check the man page. You can often turn them up, so you can do sort of -dddd to have lots and lots of debug information. And even if you don't understand what it's saying, it's useful. It can be useful for particularly the developers to figure out what's going on. Often they'll just spit reams of, when you use these options, they'll just spit lots of information to the screen, so we need to capture it. And the way you do that on a Unix machine is you run the program, and then we have an arrow to a file name and then 2 arrow ampersand 1. It's just the way Unix redirection works. Wouldn't worry too much about what it means or what it's doing, but that will capture all the messages from the terminal, shove them into a file called log file in this instance. So this goes on to a bit more advanced debugging. So I'll go through these fairly quickly to get onto the demo. This is using a program called Strace, which is a very, very useful debugging tool, but it's also quite scary, particularly because it produces huge, huge reams of output. And again, there's lots of options that you often need to do useful debugging, but generally I stick with only a few that I use all the time. So this is how I normally use Strace, is using exactly these parameters. So I'm going to try and run a program called cat/etc/shadow in this instance, which for some reason fails. I want to determine why. So I'm going to run this thing that says strace -f -e trace equals file -o log file. So I just remember that section here of all the options to provide to Strace, because they're the ones I use all the time. And what we end up with is when we've run the program, it's generated this log file. And if you look at the log file, you get lots and lots of output. But what it says right at the bottom is it's tried to open a file called etc/shadow, and it came back and it said permission denied, and that's why that didn't work. This was a very simple example, but often I've used this when I've run a program it's not worked correctly, and it's because it's looking for a configuration file that's not on the box, or it's in a wrong place, somewhere it's not looking, and the program itself isn't telling me this. So I run this, I look right down at the bottom of the log file and I see a permission denied or a file not found error. So here in this example we've got other files not found, but I'm not worried about those there. It's basically complaining about etc ld.so.preload. I don't know what that means, I'm just going to ignore that and just sort of go down and generally start the bottom upwards, in fact, and it might say something like etc mediawiki.config not found, and that gives you a good indication of what's going wrong. Strace is really powerful. You can provide these are some of the other options, so just sort of write them down so it's in the presentation. You can log times that things are happening, or how long it's taking to do various actions. So if you have a program that's running very slowly and it's taking minutes to do something rather than seconds, then often you can use this to figure out which calls are going wrong, and it might say there's a problem with DNS, for example, so it's helpful to pinpoint where the problem lies. You can also attach Strace to a running program, so if there's a program that's already running that's going wrong, you can actually attach to it and find out what it's doing. So I sometimes use this if I'm running a program and it seems to have hung, it's not doing anything, I want to know what it's trying to do, and I'll run this thing called do strace -p. So that's wrong. Strace -p, and then the process ID of the file, of the program, sorry, and that will tell me what it's currently running. And normally it's I'm trying to read this file, I'm trying to write this file, and I can see what's happening there. With Strace, it's often short, only prints the first 32 characters of each string. So if you're watching something and it's starting other programs up, you might see it saying, oh, I'm trying to run /user /local /bin /s, and then it stops just because it's hit 32 characters. So you can tell it to increase that, and that's -s. So I do something like -s 500, and that means I won't have that issue. Again, it's one of those things that when you hit it, you just need to know how to increase it. And I thought I'd put that bit of information in there. One of the issues with Strace is the logs are huge. I run Strace and you can get thousands and thousands of lines, but again, I normally just ignore them and work from the bottom upwards, or I just skip things that either I don't understand or I don't care about. And it's surprising how often that still lets you figure out what's gone wrong. Strace also really slows down a program, so if you've got a production box, you need to be really careful about running that program underneath Strace, because it will have a serious performance impact on it. But again, if you're trying to figure out what's going wrong with the program, sometimes this is the only way. The last thing, which I won't demonstrate because I did it last time at Surrey was what I did there was I ran Strace against OpenOffice, which was running the presentation, and you can see it producing lots of reams of output. And then when I told Strace I didn't want to know anymore, which you do just by literally pressing Control-C to kill Strace off, instead of detaching nicely and cleanly and letting OpenOffice continue along in the background, what actually happened is OpenOffice hung. I find that if you run programs underneath Strace that are multi-threaded, so things like OpenOffice, then often you find that it causes grief. Simple programs seem to work absolutely fine, but complicated ones, generally what you end up doing is running underneath Strace and then sort of killing the whole lot off and restarting it. Go on to shell debugging. So Strace is nice because it works with all programs, so whether they're C programs or whatever, it will give you information. Sometimes you can just do it under shells if you're trying to figure out why a certain shell script's not working correctly. Basically what you need to do here is you need to use a -X option, which turns on the debugging. So what it will do is it will print out each line before it's going to execute it. So the way I normally do this is I run bash -X and then whatever I was going to run normally. So later on I'll see, I'll demonstrate an example of this with dovecot, where instead of running etc init.d dovecot start, I'll say bash -X /etc /init.d /dovecot start, and we'll see the output that produces. And the last way to debugging is to stick print messages in it. So if it's shell script, you can do echo sort of hello $file name, that will print out a variable called file name if you can see it earlier in the script. There's similar ones for Perl, Python and Ruby. So you don't need to know how to program things like shell or Perl, but you can put messages in, so you can say, okay, it's going through this program, it's getting down to here, and then it's dying, or it's getting down to here and for some reason it's saying the wrong thing. So you're not fixing the code, but you're getting a bit more information back about what's possibly going wrong. The last bit of that I'm going to go through is network debugging. So there's two things we generally want to do here. One is to find out is if we're trying to run a service on our machine. So for example, we're trying to run a web server or an IMAP server or a POP server, and it's not working, we can't talk to it. And for that we use netstat, so we use something like netstat minus PANT, and that prints out what we're listening to. So on this example here, we're listening on port, you probably can't quite see it, it says :25 there, and that's port 25 is email basically. And we've also got another one here which is :80, which is web server. So in this example for the port 80, it says it's being listened to by Apache 2, which is our web server. And for port 25, which is the email, it actually says inetd, which is a bit of a strange program. It listens on quite a few ports normally, and when something talks to it, it generally passes that off to something else. So in this case, although inetd is listening to it, what happens if I try and send an email through this is inetd gets the request and it passes it off to Exim, in my case, to do the handling. Sorry.
What does actually, someone who's pretty ignorant, what do you mean by listen?
So if I pick the web server, because that's an easier example, if you try and say go to Google, what happens is your box tries to talk to a Google machine, and it talks to it on a certain port. So it just by convention, on the web you normally use port 80, so it tries to talk to this port 80, and something on Google side has to listen for that, because otherwise what will happen is your network traffic will go to Google and will just basically get binned. So there's a program running on a Google server that will listen for that, listen on port 80. When you try and talk to it, it goes, aha, okay, you obviously want some information, and it will send you the web page back. So the example I'll go through, what we'll be trying to do is have an IMAP server, which is like it's an email server for you to pick up emails from. And in fact, it's an example from Ian. So he was trying to get this server running on his machine so that he could basically pick up emails from that. And for some reason, it wasn't running. I'll go through exactly why that was and what we did to fix it. The more complicated way on how to do network debugging captures all of the network traffic. So particularly when it gets to this level, unless you know networks quite well, it's difficult to figure out what's going on, but that's okay. If you've collected the information, you can often give it to someone else and they'll look at it and they'll go, aha, I see what's going on. So to be honest, I did these, and I like using command line tools because they're always the more commonly available. But for most people, you're probably best using something like Ethereal, which has now been renamed to Wireshark, so it's a bit more a graphical tool to capture information. And what you really want to do is to capture the information, save it to a file, so that you can send it to someone to have a look at. I'll go through this. This is some of the sort of common options for TCP dump. So they're in the presentation. And as I say here, you're probably best using something like Ethereal or Wireshark to do the capturing. So I'll go through that in the demo, the easiest. Once you've done all of you've tried to fix the problem and have a look and capture the information to determine what's going on, where do you turn to for help? So obviously rural ag, we've got a mailing list, so mailing lists are good. You can either go for the ones from your lug, or there's ones for most projects as well. But again, it's the ones for the projects, it's generally advisable to at least have a look or try and do a search, because the last thing you want is 200 people all saying, I've got this problem, and the answer is, yes, we've just answered that question already 150 times. So an example would be, say, the recent Ubuntu release where there was an issue with the X server. It broke X Windows for a lot of people. Fairly quickly there was okay, this is what's gone wrong, this is how you need to fix it. But I'm sure they were still inundated with people saying, oh, this appears to have broken. And if it's just, you're on a mailing list, you don't want people wasting a lot of time by saying, I can't be bothered to use Google to look up what this error message was, although there's all this information there. it's just polite to try and fix your own problems. There's internet relay chat, so there's the Hans channel that some of us hang out on, not necessarily all day long, but from time to time certainly, and that's quite useful in that at least you can cut and paste snippets of code or output quite quickly. And the last one is to file a bug using one of the websites mentioned earlier, say for Debian, Ubuntu, Fedora, or the projects themselves. So including you need to have things like what version you're using, the output, what you did, what the error was. So for example, I filed one recently about a program where I said I could see what was happening. It wasn't in a configuration file. I had something like username space Fred, and instead of treating the username as Fred, it was treating the username as space Fred. So it's fairly, and I did that one by capturing network traffic and to see what username it was sending over. So I haven't fixed the code, but I sent a message to say, this is what my configuration file is, this is what I've seen being sent over the network, so this is the version number I'm using, so that they can go and fix that. So those are basically just a very quick run through of the programs that I use. It's a lot easier to do debugging if you're sat next to the computer, which is why we have ringer box meetings. Trying to debug all the problems over a mailing list is very, very difficult. At the end of the day, the more information you can provide, the faster people can fix the problem. Particularly if you can even find it on Google, you don't even need to wait for someone to reply to you.